In this demo, we'll look at how to replicate the containerized application WordPress from GCP OpenShift Cluster to IBM OpenShift Cluster and how to set up the DR. Now let's look at both the environments and the application. So this is the list of virtual machines that forms the GCP OKD cluster, and we've created it in the US Central 1 region and have deployed the WordPress application onto this cluster. Now let's access the console. So this is the project where we've deployed the application. And in the workloads tab, we can see there are two workloads, one for the front end of the application and second is the backend. Now let's go to the overview tab and check out the inventory, which lists all the OpenShift objects that belong to this WordPress application. Now let's access the persistent volume claims. So there are two PVCs and both are using the standard GCP persistent storage. During the replication, Swift will convert the storage into the IBM block storage and also create all the OpenShift objects onto the IBM OpenShift cluster. Now let's access the application. So for that, go to the services and select the WordPress service. And you can copy this IP address into the browser tab to access the application. So this is the application that we are going to replicate today. And we've created a sample post here. Target environment, which is the IBM OpenShift cluster. It is created in the Dallas region. Now let's access its console. So before starting the replication, we pre-created an empty project here named as WordPress and also created one secret here, which is the RackWare try secret. This will configure access to the registry where the try image is present. Try stands for RackWare transient agent image. During the replication, Swift creates a pod which is based on this image onto your cluster for the staging purpose. In the current release, this step is manual, but in the upcoming release, we've automated this process and Swift will create a secret for you. Now let's look at the Swift server details. So we've created a Center 7-based virtual server on the IBM Cloud in the Dallas region, which is same as the region of IBM cluster. For DR use case, we recommend that you create a Swift server in the same region as your DR region, because if in case some disaster happens in your production region, then you don't want to lose the Swift server and the backups that it may have. Also, we've added a block storage here, extra storage of 50 GB. But for migration use case, this step is not needed. Now on this virtual machine, we've installed the Swift application. To access the application, you need to copy this IP address and append the Swift dashboard endpoint to it, and you'll be redirected to the login page. During the Swift installation, you'll be asked to set the password for the admin user. And after that, you can also add multiple users to the Swift. And if in case you need to see some operations guide of the Swift, you can download it from here. For now, let's log into the Swift machine. Before starting the replication, you need to add both the clusters to the Swift. So let's add them one by one. Let's provide some friendly name to the GCP OKD cluster. And let me just fill in the rest of the details here. Let's click on the add to add the cluster. Similarly, let's add the IBM OpenShift cluster. The cluster is now being discovered. Okay, so after the cluster is discovered, you can expand it and check out the details like the projects tab. You can see all the projects that are present on your cluster. Let's search WordPress. And in the WordPress, we can see that there are two pods created. And by default, the pod kind is selected, but if you want to see another type, you can select it and objects of that type will be displayed here. Now the next step while setting up the DR is to configure the Swift storage. So for that, you need to create a storage pool here. Let's provide a friendly name to it, backup pool. And Swift will list all the devices that you can add to your storage pool. Let's select one and add it. And if in case you are not sure, you can always log into the Swift server and cross-check the device details and just add it to the Swift. The storage pool has now been added. You can check out its details here. So now let's create one DR policy here. So provide a friendly name to it, Arly. So there are three types of policies you can create: pass-through, which is for the migration purpose; stage 1, which is for the backup; and stage 1-2, which is for the DR use case. Now you can provide a separate schedules for the stage 1 and stage 2 operations, which are executed as a part of the stage 1-2 policy. For now, let's select hourly schedule for the stage 1 and select execute after stage 1 schedule for the stage 2 sync. To receive the DR alerts, you can configure the email ID here. If you want to receive the DR alerts only in case something fails, then you can check this box. Let me just create the policy here. The policy has now been created. Now you can directly apply this policy and provide the sync options to start the migration and start the recurring syncs. But we recommend that you execute the migration initially by hand and then apply the sync jobs to the policy. So let's start the stage 1 and stage 2 jobs here. Let's create a stage 1 sync job first. So select the stage 1 type, select the source friendly name, which is the cluster of GCP, and select the project where the application is deployed. The next option is whether you want to sync all the applications present inside your project or whether you want to sync a particular application. So since only WordPress application is present in the namespace, we'll be selecting all applications. Now let's provide the name for the target, which will be a local backup for the WordPress application. The next set of options is the tripod service options. So you can either select this if you have this port range whitelisted in your cloud firewalls, and if in case you haven't done that, you need to provide the specific ports here. So let me just put in the port here, and you need to provide the image friendly name, which is a try image name, and just provide the initial job name and click on the add button to start the sync job. The stage 1 sync job has now started. Let's wait for it to complete. Stage 1 sync is now complete. Let's initiate the stage 2 sync job similarly. Target in this cluster will be IBM OpenShift cluster, and the project is the WordPress, which is an empty project we created beforehand. We can select the list of storage here, and let's select the IBM block storage and select the zone in which your target volume should be created. Now let's fill in the rest of the details here. In the advanced options, we have some customization options available. Like if in case you want to select the type of your service, so you can select that. Like for example, well, you can change this to the node port or load balancer service or any other type that you want. And similarly, you can also change the port of your service. So you can select the service here and select the port that you want to change and click on this and randomize it. And you can add this by clicking this plus button. So this customization will be applied by the Swift during the replication, and the replicated service will be using this input. Now, if you want to include or exclude a particular volume from the sync, you can do it in here. And now let's click on the add button to initiate the stage 2 sync job. Let's wait for it to finish. The stage 2 sync is now complete. You can expand the job to see this object sync statistics and the data sync statistics, and you can check the summary here. Now let's, in this way, we have migrated the WordPress application from GCP to IBM cluster. Now let's access the replicated application. So go to the console of the target cluster and select the service and copy paste this into the browser tab here to access the target application. So we can see that the migration was successful. Now let's create a sample page onto the source application. Provide a title here and publish the page. We have created a sample page here. Let's apply this DR policy to the stage 1 and 2 sync jobs. So let's select both the jobs here. Here you can schedule the execution immediately, or you can start scheduling the DR policy at a particular time. So let's start immediately for now. And let's click on the apply to apply the policy. DR policy has now scheduled the stage 1 sync job. And after the stage 1 sync job, it will schedule the stage 2 sync job. Now let's wait for both to finish. Stage 1 and stage 2 is now complete, and the DR policy will schedule the next stage 1 and stage 2 after 1 hour. Now let's access the target application again to see if it has any reflected changes. So let's just open it here. And we can see that it has created a new page on the target app too. So let's go to the DR policy. And if in case some disaster has happened in your production area and you want to fail over the policy, then you can do it here. So during this, Swift will identify whether there is some outstanding changes that haven't been yet synced to the target. If it is the case, Sync will transfer that data and sync the application. But if in case there are no changes, then Swift will simply change the policy state to the failed over. Now let's fail over the policy in the drill mode, which is the test mode. And it will simply change the state of the policy to the drill failed over. And if you want to fall back the policy and make the DR side, make the source side active again, then you can click on the fallback option. The policy state has now been fallen back.